I am Max Wyss. I started my career in Switzerland. In Zurich, I got a diploma from the Federal Institute of Technology, and later I became a seismologist. Now I'm retired, and I would like to give back a little bit of my expert knowledge to society. The way I do this is by estimating losses immediately after earthquakes. What does immediately mean? It means in 30 minutes, I make an estimate of how many people are dead, how many people are injured. And that is transmitted to first responders who then can get fast onto the scene. Very first thing that happens is the earthquake itself. Houses collapse, people are hurt and injured, but in the world nobody knows anything about this. Now I get a message by my SMS. I have telephones here too, so in case one is failing, then the other is still reporting. And I calculate how many dead, how many injured, approximately, this is my estimate, and I transmit this to anyone who wants to receive this message. The important thing, of course, is that first responders will look at my message. What is my message? Look at this slide now. On the left top, it's the input. Epicenter, depth, magnitude. I need to know that to calculate what's on the top right. The number of fatalities, the number of injured, as I think it is. And in the middle, we have a map of mean damage for every settlement in my dataset. The damage to houses is important because it's buildings that collapse that kill people. The earthquake itself does not. In order to make this calculation, we have to have information for the whole world. This slide simply shows a black dot for every settlement that we have in the data set, and these are nearly 2 million settlements. What do we know for a settlement? Coordinates, name, number of people, and a model for the buildings present in the settlement. Now I want to tell you quickly what actually happens. First, you see an earthquake happens, waves are traveling through the earth, and they have to arrive at stations. That takes a few minutes. Once they arrive, international locations like the US Geological Survey or the center in Germany at Potsdam calculates the epicenter. This is X and Y, is latitude, longitude. Z is depth, M is magnitude. Now we have a first model of the earthquake itself, a simple model, just a point source, X and Y. Next, now I get that information. Next, I have to consider the transmission of seismic waves through the earth. Sometimes, in some places, the transmission is good, in other places, less good. And if I know that, I can build that in my program. It's programmed, and I can choose different attenuation, one calls this, transmission properties. From this, I calculate the impact on the buildings, and that is the most important thing because the impact on the buildings is what makes damage to the buildings. If the building collapses, it kills people. It's not the earthquake itself. So I have to know how many people. So the next thing is the impact on the people. And I calculate the probability, how many are dead, how many injured. And so then our results are building damage and fatalities and injured. That's the QLARM job, and I framed it here so that you see clearly what the QLARM job is. At the very top is the input I get. Now I framed the part that I do, and at the bottom you see the response. It's out of my hands. I then hope that the first responders and the government, the authorities in the countries affected, make the right decision to the ultimate aim at the bottom right. You see, helping the people who have been impacted by this earthquake. So here we have a model of a big city. Big cities are always the top concern for some people because, of course, big cities are where most people live, big cities are where the greatest casualties occur, And it's also a point where one can go to and say that is the worst case in this earthquake. And this is just an example to show you. In this case, Lima, Peru. It is close to an earthquake belt, so we make a model for a magnitude 8.5. And what do we calculate? We calculate the mortality in each district of the city. What is a district? It's a predefined area of administration. So actually it's not geology. We would like to have predefined volume of bad soil or good soil or different building properties. The villa district is different from the industrial district, which is different from downtown, a mixture of buildings. But we don't have that information. That's what we would like. So here I just show you how is the mortality to be expected in different administrative districts. In Mexico, we know, everybody knows, that there is a trench offshore the western coast of Mexico that produces large earthquakes. Historically, there has been a really large earthquake about 500 kilometers in rupture lengths. So I model an earthquake that you see here as a rupture of 500 kilometers and give it a magnitude of approximately 9. Magnitude 9 is pretty much at the upper level, the maximum that we can expect. And here is a map of mean damage. Red, of course, terrible situation. Blue is minor. Now, I think the value of a map like this is that we have an idea of what should first responders, what should medical people, hospitals expect to happen? What should they be ready for? It is also clear that we don't have enough information to do the best job we could do. We could do a much better job if we had more information. And especially, we would like to calculate losses in hospitals so that the first responders are not transporting all the injured to the wrong hospital. We would like to calculate the damage in schools because the children are the most precious part of society. And so we think that we need better data and we need support from the population in getting that. And if we do, then we have very good estimates of future losses of earthquakes that are likely to happen. And we would like the population and the governments to pay attention and improve their building structures in those places where we expect great damaging earthquakes in the future.